Wow, jialat. Okay, I need to go and get it checked. I'm so sorry. Okay, continuing. What was I saying? Right. So U is on the top left. Then what's on the top right? Must be
V
no.
prime.
B prime. Correct. Okay. So let's see. Without the formula, you can actually solve this. Just remember, left diagonal minus away the right diagonal, and you must have the correct choice of the top two letters. Once you remember U and V prime, the rest is okay already. What's directly below U?
U prime.
U prime. What's directly below V prime?
V.
V. Okay, good. Black color, yellow highlight, and blue highlight are the ones you should have as a template. Okay, so now you have to pick. How do you select your U and V prime this time when both of them involve algebra? Can you still use your LIATE? The answer is you cannot, right? You see the problem here? So that's why we're gonna be a little bit clever. If you try to go for the idea of, oh, the easier guy to integrate, we're gonna select as V. Let's see what problem this will bring up. Okay, I'm gonna duplicate this so I can do it correctly later. Now I show you the wrong way to do it. More like you have to do guess and check. No choice on integration by parts. Only experience can help you to save time and know which is the correct one to choose. So here's x and here is root x minus 2. Because I like to integrate easy things. So integrate x, I get x squared over 2. Then differentiate square root, I get 1/2 x minus 2 power negative half. Right? Okay. Then let's try and do this using the one that I just found. So this must be what? Equals to yellow diagonal UV, right? So what would that be? Root x minus 2 multiplied by x squared over 2. Okay, good. Then minus away integral of v du. V du. Du is u prime. What do you get? The blue color, right? Tell me.
Yeah.
Tell me.
U prime times V.
Very good. And then you times the v, which is x squared over 2. Wow. Oh my. What is this? How to integrate? Can you integrate or not? You clean up a bit, you get over 4. X minus 1 power half is square root x minus 1 and the denominator, right? Then x squared on top. How to integrate? You just made the problem tougher, correct? So that's why this is a wrong choice of u and v prime. You only have two vectors here, right? So you just guess and check. In this case, somehow for this particular choice, it doesn't work out. So that's when you have to redo the table. This way doesn't work. Then you have to redo the table, redo this question. That's how integration by parts work. Guess and check. Okay, so we redo the question. Now this time, x minus 2 root times x dx. So sometimes the moral of the story is sometimes choosing the easy way out is not the best way. As what we have seen. Integrate x is the easy way out, x squared over 2. And it fails. It doesn't work out. It ends up being more difficult. So that's why we have to swap it around. X on the left, root x minus 2 on the right. Sometimes the difficult way is the only way. Sometimes the difficult way is the only way. Let's see how we do this. Can you integrate root x minus 2? Can you integrate this on the right side? Yes. X minus 2 square root is just power half, right? How do you integrate when it's linear inside? Remember? Ax plus p power n, you integrate, what do you get? Copy the base, add 1, get the new power, divide by the new power. Don't forget to divide by coefficient of x. Because it's a reverse of differentiation. Differentiation, you have an a inside, you have to times a because of chain rule, right? But here, in integration, you reverse.
Divide.
This one is just using power rule. Add 1, get the new power, divide by the new power. Add 1, get the new power, divide by the new power. Memorize. Add 1, get the new power. Okay, so here is what do you get? What's the base? X minus 2. Add 1, get the new power, half plus 1. What do you get? 3 over 2.
3 over 2. Then
divide by the new power, 3 over 2. And then you times the a. A is the coefficient of x, which is 1.
Nothing.
Then you don't need to do it, of course. Good. Simplify to make it look nicer, I get 2/3 x minus 2 to the power of 3 over 2. Okay, then for the other guy, differentiate x, you get 1. Is that okay?
Yeah.
Then now use formula. What is it equal to? uv minus integral u prime v. Yellow minus away integral blue.
Mm-hmm.
Tell me.
X times.
That guy, okay, good. Yes.
Yeah.
Let me just
And then
copy. Wait, okay, continue.
minus integral of that guy.
Which guy? Okay, that guy. Okay. Actually, I realized I already simplified it. I should use the simpler version. Give me a second. Duplicated the wrong thing. Like this, minus integral of that guy. Then
Dx
times 1 to follow the formula, right? U prime then
times
times v,
1.
then times dx. But of course, times 1, you can then simplify it. Do you get what I'm saying? This is the blue part.
Yeah.
You know? Okay, then you have to think carefully about this expression. 2/3. Okay, this one nothing already, just copy and paste. Can you integrate this guy? 2/3 factor out first. Can you integrate x minus 2 power 3 over 2? When it's linear inside, this is essentially 1x plus negative 2 bracket to the power of 3 over 2.
Yeah.
You integrate?
Can.
Can,
Yeah.
so now integrate it. What do you get?
Okay. You get x minus 2 to the power of 5 over 2 divided by 5 over 2.
Very good.
Times 1, but then
Times
we
1,
just
but doesn't do anything exactly. And then the left-hand side, just copy and paste it down, and you solve the integral. Ta-da! That's your answer. You can prove that it is correct by differentiating it. By the way, do you know what is Symbolab and Wolfram Alpha?
is it a thing? Is it like a website? Then you like print like the thing, then it'll tell you.
Yeah, I'll tell you the
what-
answer straight away. You can say,
And
you can type in English, differentiate this expression. But the problem is you
won't,
need to
won't
know
it,
how to type.
won't it ask you to like pay before? Like it won't show you the answer. It will like ask you to pay.
Yeah, yes. The full work solution, yeah, they will have to get you to pay. But there is another website called Integral Calculator. Yeah, all free things will eventually become paid. For now, while it's free, just make use of it. Integral Calculator, I think that's the website. You can go and find. Later, I send you a link. You just need to learn how to type the expression. You try to integrate this guy. This guy are very powerful. They will give you every single step done by a computer on how to integrate. Everything I explain as a human, the computer can do it. And the instruction and the explanation is very clear. You can go and read. I'll send you the website link later. Then you can play around. You will get the same answer. But they simplify it for you. I'm not going to simplify this. You're going to do it yourself. Okay, don't simplify. If not, I also cannot understand the working if I mark your work. All right, that is integration by parts. Let's try one more idea, which is parametric integration. So let's see. There is this idea known as a parametric function. Let's look at this example. Integration of a function defined parametrically. So that you can have a curve, it's not a function. Function means what? For one x value, you only have one corresponding y value. Usually in a parametric curve, it does not look like a function. It will curve something like this. I can curve like this. Then it will have a vertical line that will intersect multiple times. So it's not a function. It's a relation. Then anyways, let's say that you have a function, a relation defined parametrically as y equals to 2t3 minus t, x equals to t squared, t more than equals 0. You can use software to help you to draw this graph. Let me show you. Where is my parametric calculator? Okay, you know what, I'll just use a GC. Wait. Loading. Still loading. Hold on. There we go. Okay, so on our GCI, you can quit it, and then you go to not window. You go to mode. Okay, then there is what's known as the parametric mode. Okay, parametric. Press enter. Then you go to y equals. You key in x. In this case, it is t square. X square. Then the other guy is 2t 3 minus t. So the variable here, this is the button. You know where's the button? To the right of alpha. Yeah?
Yep.
Then bracket 3 minus t. Close the bracket. Okay, then this is restricting to t more than equals 0. So you go to window, you see that you'll change to t min, t max. So you start from 0. Let's just make this into, I don't know, like maybe 6 pi. 6 times of pi. And dot. Okay. Then this is step size, means they are basically plotting many different points, and that's how you get a smooth curve. Let's just draw the graph and you'll see. Oh no, you cannot see anything. Go to zoom. Z standard is number 6. You can scroll down and then press enter, or you could have just pressed 6 straight away. Number 6. What's that? That's the curve. Can you see? You see the curve? It goes up and then it goes down. Oh, that's the parametric curve. Okay, using software, you can help you to draw. But more relevantly, how to solve a question involving integration. Let's say that you have this parametric curve and you want to find the area bounded by the curve and the x-axis. Give me a second to share the screen. So let's read the question. The curve meets the x-axis at x equals 0 and x equals 9. Here and here. Oh, just now you see in area, it goes all the way down. So I stop at x equals 9 and I define this region R. The shaded region R, sorry, I didn't shade it, it's this region, is bounded by the curve and the x-axis. Now we want to find the area of R. So definitely to find area, you need to use what? How to find area? Integration. You already learned before in Amex. Just integrate y dx, right? From a lower limit. So in this case, x equals 0 to x equals 9, right? Whatever is the function. It's just that this time the function is a bit funny. It's parametric. Yeah? So that's when you have to do something known as parametric integration. Here, you must remember this is the formula. Integrate a y. But here, you must do something similar to integration by substitution. Y is equals to 2t 3 minus t, so we can replace it with 2t 3 minus t, yeah? Remember for integration by substitution, there's 3 pieces of the puzzle. The left piece, the middle, and the right piece, the hamburger, right? So the left piece here from 0 to 9, this is x equals to 0 to x equals to 9, because you're starting from 0 until 9. So we're going to write in x equals 9, x equals 0, and we sub in into the formula for x. Do you see the formula for x? T squared equals to x. Yeah. Then you just have to sub in, you get 9, you get 0. And from there, you solve for t. Because they ask for t more than equals 0, by right, you square will have plus minus 3, right? Square of 9 is plus minus 3. But here, because we want more than or equals to 0, more than, so you have to reject the negative. So t equal to 3 only. For other guy, t is just equal to 0. Okay? So we update it to t equals 0 to 3. Is that okay? Just be careful. Some students, blah, blah, they'll put a 3 here at the bottom and 0 at the top. They mix up the order. I don't know what happened. 9 stays on top. 9 is on top, it stays on top. 0 stays at the bottom. So just don't mix it up. Is that okay? Like this. On top, below. Clear? Yeah, now first half of the puzzle. Next half is y just replaced with an expression 2t 3 minus t. That's easy. Then the third piece is dx. How do you get dx? X equals t squared, how do you get dx? Differential dx by dt. Is that okay?
Yeah.
Dx by dt, you get 2t, then you can make dx a subject. Pretend this is a fraction, divide by 2 dt. My calculus professor will scold me for saying this is a fraction, but for practical purposes, you can pretend it's a fraction. Divide by dt, you can just treat it like a denominator and bring over, you get multiplication. So dx equals to 2t multiplied by dt, okay? Just for now, it's good enough. The theory, don't worry too much about it. Becomes 2t dt. Then you can substitute in, you see? dx here becomes 2t dt. Clear? Clear? Great. Now we have this guy. Do you know how to integrate? Can you integrate this? In terms of t? Yes,
Yeah.
right? It's just long-winded. Not difficult. Blah, blah, blah. You expand everything. Eventually, it simplifies down into 3t squared minus t cubed. Then you have a factor 4 as well. Factor out. Then just integrate, blah, 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 sub in the upper limit 3, lower limit 0, and you get your answer. That's your area. Unit square. Okay? Parametric integration done. It's just substitution. Is that okay? Understand? Good. Okay. Next one, volume of revolution. Wow, do I have time to talk about this? For volume of revolution, it is talking about the idea where you try to find volumes when you rotate a certain curve about the x-axis. Okay, so let's think about it. If you have a curve that looks like this funny function y equal f of x, then can you imagine how you find the volume of this sort of bell shape when you rotate? Can you visualize this bell shape that's going on? If you rotate it around. Or if I make it a bit simpler, let's start with a simpler shape. Let's say you have a straight line. Then if you rotate it around, can you visualize this? Maybe let me see if I can. Hello. Is it showing? Actually, I need to see. How is the video showing? So you must visualize it like this. Hi. You rotate it like this. There's a line, then you spin around. Okay? Then what kind of shape will you get? Like this. This is the x-axis. Then here's the line. Hi. You rotate it around.
Yeah.
What kind of figure will you get? Can you visualize?
Like.
Okay, maybe I use my hand like this.
Okay.
Like, imagine, what shape do you get? 3D shape.
Like.
How do you describe this? Like, it looks like a triangle, but then at the base is a circle. Okay, hi, bye. You reflect it down. What is this shape? Cone.
Cone.
Correct or not? Cone. Can you see the cone?
Okay.
Right, it's a cone. So that means that if you rotate a function about x-axis, a center, you get a cone shape. So our question is, how can we find the volume of this cone? Here's a clever trick. What if we break it down into tiny pieces of very, very thin, what we call cylinders? What's a cylinder? Cylinder is like this, right? You have circle. So I'm testing my art skills like this. So the area here is a circle, right? So it's pi r square. And this is the height. This one, if you pay attention during D&T class, then you will know. Pi r square then times h, right? Now we make it extremely thin. Extremely thin cylinders, like this. Can you visualize this? The h is very, very small. The r is still here, r. Then you have pi r square h for the volume of one such small cylinder, thin cylinder. Clear so far? We're going to draw many, many copies of these cylinders. Another copy, guys. You see, this one testing my art skills. I hope you can see, And another cylinder like this. A bit difficult to visualize. I hope you can see what's going on.
Yeah.
To approximate the volume. So if you add up a bunch of these cylinders, right, you eventually get the volume approximation of the volume of the cone, right? It's a pretty good approximation. It's just that there's a pink color gaps over here. Pink color gaps over here in 3D space that's missing, correct? These are the errors. But I think you can tell, if I add more and more and more of these cylinders, thinner and thinner, then it will become closer and closer approximation of the actual volume, correct? Can you see that? If you add more cylinders, then the approximation will get better. Yeah? Can you accept that?
Yeah.
Break it down into a bunch of what we call disk. You add a bunch of these, so you can essentially approximate the volume of this 3D figure, what we call the volume of revolution. Revolution means you spin one circle, by adding up the volumes of each of the disks. So if you add up the volumes of these disks, right, how do you do that? It's really just finding the volume of one such cylinder. So let's figure out the formula for the cylinder. It's just pi r square h, right? Base area times height. Yeah. But here you have to be clever and realize that the radius is this guy, which is actually just fx here. It's really just the y coordinate. Correct? So that means that the volume of one such blue color cylinder, right, It's actually in general pi times y squared times h, or what I like to call delta x. Delta means change, x means because it's along the x-axis. Oh, this is the height. The height h is delta x. So I write down as pi times y squared times the h, but with funny notation. The height here, blah, blah, blah. The radius here happens to be the y. Can you accept this? Like if you have a point here, that's an x comma y, right? The y happens to be this guy here. It's also the height, or it's also the yellow color radius of this cylinder. But this delta x here is the height, or more like the width of this very thin disk. Then if you want to find the entire volume, isn't it just adding up a bunch of them, add all of them together? A summation, right? This is just a funny notation for summation. Okay? Then you can factor out a pi from here. You end up with pi times summation of y squared times dx. Then I hope you can see this sigma notation looks just like the integral symbol, right? Okay, roughly. And this delta x here looks just like a dx. Right? Then how do you convert from a sigma? I know I never fully explained to you the sigma notation before, but sigma just means sum. So for example, sum of I equals to 1 to 3 of 2i plus 1 means I substitute with 2 times 1 plus 1. That's the first copy. And then 2 times 2 plus 1. And then plus 2 times 3 plus 1. I'm running out of space. Oh my. Can I just restrict this to 2? So we replace the I equals to 1. Replace the I equals to 2. Well, this is the notation. But you don't need to know so much in details for now. Just take the limit, then this will eventually become the integral. Then this becomes pi times the integral of y squared dx. Why do you have a square? It's because of the radius square. Okay so far? So this fella here is now the formula for the volume of revolution, pi y squared dx. For the one with the other case where it's in terms of about the y-axis, I talk about it later. So let's look at one example. When you have y equals square root x, you want to find the volume of revolution, right? What you do is you consider from x equal to 3 to 4, you get 2 lines. This is a piece of a rectangular trapezium looking shape. You're going to rotate it about the x-axis, you get a volume. How would you find that? Just use the formula, pi integral y squared dx, but the lower and upper limit must be replaced with the small x and the big x equal to 3, x equal to 4. Then the y you replace with root x, bracket, bracket, power 2, because y squared. That is the formula. Just type it in, and you'll eventually get the volume of the figure. I think it's better if I try a simpler example. Let me show you a simpler example, okay? So let me do that. If I try a simpler example, it will be y equals to x. Let's say that we have the cone. What's the formula for volume of cone? What's the formula for volume of a cone?
Volume of cone pi r square h times 1/3.
Let's try and prove it using volume of revolution formula. So what is the function here? Let's say this is y equal to x. Then how do you find the volume? That just means we have v equals to pi integral of, let's say this is from 0 all the way to 3. So the height here is 3, okay? So if in this case y equal to x, right? So what's the coordinates of this point is 3, 3, right? Okay, maybe I make it a little bit more interesting. Y equals to 2x. So this will be 3, 6, yeah? I'm not drawn to scale. Okay so far? Can?
Yeah.
Okay, then in this case, might be better if I draw it to scale, if not you get confused. Like this, roughly. So there's the radius, r equals to, in this case, let's say it's 3, 0 to 3, and this point here is 3, 6. This is y equals to 2x. Y-axis here, x-axis here, origin there. Okay, so what's the formula? It's actually pi times y squared times dx, right? but then you must go from 0 to 3. What's my y in this case? It's 2x. So 2x bracket square dx. Right? Then let's calculate this. Pi times the integral of this guy. 2x squared becomes 4x squared. Integrate dx from 0 to 3. Factor out the 4, you get 4 pi integral of x squared dx. 0 to 3. Integrate this guy, you get 4 pi times x power 3 over 3, bracket 0, 3. Sub in, you get what? 4 pi times 3 cubed over 3 minus away 0. Factorize, you get 1/3 times pi. Oops. 1/3 times 4. Okay, let's see this first. You know what? Let's just simplify. So 3 cubed over 3 is just 3 squared, which is 9. 9 times 4 is 36 pi. Okay so far? Using the formula, I get 36 pi. Yeah? Then now let's try and calculate it using the formula we know since primary school. Not primary school, secondary school. It's 1/3 times pi times radius square times height. What's my radius here?
3.
Oops, sorry, wrong. Label wrongly. This is not radius. It is radius, but it is not 3, it's 6.
6.
Correct?
And then
No.
height.
The height is 6, 2x. X equal 3, y 6. So that means this is 6, then the height is 3. Let's calculate this. 6 squared is 36. 36 times 3 and 3 cancel away. So you end up with 36 pi. It's the same answer. Eh? Oh. It's the same answer. Of course, it's not a coincidence. Okay. Okay. So this is the volume of revolution formula. This is how you derive the formula 1/3 pi r squared h, actually. All right. Then later I'll give you some practice questions. Wow, it's already 12:30. Can I go through one more idea? Give me 5 more minutes.
Oh.
I go through one more idea, which is integration of a separable differential equation. So next idea is separable d. So let's say you have dy by dx equals to x squared. How would you solve for y?
I was gonna say integrate, but then
Correct. Exactly. That's it.
okay.
Then you get x power 3 over 3 plus c. That's your answer. Differentiate forward, then you get this. So to what by what you integrate. That's when pay attention here. It's x and x. But now let's upgrade this. Let's say that I have something dy by dx, but this time it's equal to y. Can you still integrate? What you're really doing when you integrate is you integral of dx on both sides, right? Then you end up with, let's see, dy by, I want black pen. dy by dx and y. Then here, integral and dy and d will cancel away, dx cancel away, you're left with y, yes. But here you have integral of y dx. Is that allowed? Cannot, right? If we know what is y, then we can solve this. But here we don't. What's y? I don't know. Right? So that means here's how you have to deal with this question. This is what we call separable differential equation. First thing you must recognize is y and y. On the right-hand side, it is in terms of the dependent variable. Previously, it was easy when it was in terms of the independent variable. Okay? The dependent variable over the independent variable. Well, right-hand side now happens to be f of the dependent variable. Okay? So how do we deal with this? Dy by dx equal to y. Wow, just by changing the type of letter from x to y, it becomes a lot more difficult. You've never seen this before. This is what I call separable differential equation. So do it again, dy by dx equal to y. But here's what you do. You read this as y times 1, then you do the reverse of cross multiplying. So it's really just 1 over y dy by dx equals to 1. Clear? Right? Then we have to integrate both sides with respect to x. Now that it's a 1, it's very easy to integrate. It's just x plus c. Correct? Right hand side. Yes, but for the left-hand side, it's a bit more special because the dx can cancel away. Then look carefully, what are you left with? 1 over y dy, right? Oh, how to integrate 1 over y dy when the letter is the same? You can proceed, right, as per usual. Ln modulus y. Yes? Correct? Ln differentiate, then you get 1. But make sure you have modulus signs. Must have modulus. To make sure that the y is positive. If not, you'll get negative, then it's undefined. Equals x plus c. Then the objective of differential equation, right, is to solve for y. The goal is to solve for y. In differentiation, right, we go from y, our goal is to solve dy dx. Now, the goal is to start with dy dx, you work backwards until you get y. This is our current goal. This is previous. When you do differentiation, you go forwards. Now the goal is to work backwards. Is that okay? It's a bit like S, V, and A. Displacement, velocity, acceleration. Now you work backwards. Oh. So how do you solve for y? Let's continue. So modulus y, we have ln I is log base e. You bring over to other side, it becomes e power x plus c, which is actually e power x times e power c, correct?
Yeah.
Same base, different power multiply, you add the power. I'm gonna do one more step, e power c on the left, e power x on the right. Now if I want to, this is modulus y. If I solve for y, what do? Open up the modulus, you must introduce plus minus, right?
Plus.
So plus minus e power c times e power x. Okay, good. Then in this case, we're going to do a clever substitution. We're going to say let y equals to capital A e power x. Always have this substitution where a equals to plus minus e power c. Replace it with a constant because e is just a constant, 2.718281828. C is also arbitrary constant, right? Then constant to the power of constant, still a constant. Plus and minus just changes the sign, doesn't matter. So you just get a constant times e power x. Then that's your answer. So how do you solve for a? Here's how you can do it. Maybe at the beginning, I can tell you, initially, y equals to 10. What does initially mean? It means that I shouldn't say initially. I should say at the beginning, at x equal to 0. If x represents time, then initially means t equals to 0. Can you accept that? If x is time. Then in that case, what you do is you just have to sub in what we call the initial conditions. X equals 0, y equals to 10. You end up with 10 equals to a times e power 0. What's e power 0?
1.
So a times 1, which is a. Therefore, 10 equals to a, which you can conclude y equals to 10 e power x. That's your answer. How do you double check? Let's check out y equals to 10 e power x. dy by dx, I get what? 10 times the same thing, e power x, which is equals to y. Right? 10 times e power x is y. So my answer is correct. Can you see that? Yes?
Yeah.
Then now I want to draw the graph of this function. How do I draw it? Here's how you draw it. Exponential graph. Go up. You can use your GC to help you to draw the graph. Okay? Can Okay, let's try one more example, okay? One more example. This is example 3. Let's say that I have dy by dx, but this time it is equal to something a bit more complicated. Let's say it's x times y. Then here's what you do. Whenever you have y, right, you have to divide over, not minus, divide. So what we're gonna do is 1 over y dy dx equals to x. Then I integrate both sides dx. What I end up with is the dx cancel away. Then you're left with integral of 1 over y dy, which is just ln of modulus y. Okay? This part here is equal to integral of x, so you get x squared over 2 plus c. Okay? And
okay.
Then here, let's see what happens. What I have now is modulus y equals to e to the power of x squared over 2 plus c, the whole thing. which you can split as e power c times e to the power of x squared over 2, yeah? Can you see that? That's our
Yeah.
modulus y. Then how do you solve for y? You just get plus minus e power c times e power x squared over 2. Then what do you do next? You will replace this whole thing with a. Okay? You say where a equals to plus minus e power c. It's the same procedure every time. Just remember, divide. And then that's your answer. Ta-da! Okay, I think that's all for today. I'll give you some homework questions. Integration by parts and differential equations and Maclaurin series.
Okay.
And that's all.
Okay.
Can
Can I even know when you upload the video?
Okay.
I think I definitely need to like watch it.
The video may be incomplete. Okay.
Oh, okay. Yeah.
All right. Thank you.
Thank you. Thank you.
Thank you.
Yeah.
Bye-bye.
Bye.
I'll send you the file.
Thank you.